Welcome, reef fans, for this installment RODI water and an RODI unit. We're going to talk about what it is, why I need it, how it works. So I've got an RODI unit that I use. I've been using it for quite some time now. It's the Kent High S model RODI unit. I highly recommend it. Go out there. There's a lot out in the market. Choose the one that best suits your needs. But definitely you'll need one. Why? Well, why do you need one? First of all, we're running a reef tank here. These animals and these fish, we have to do them justice. We need pure water. Our tap water is just not pure enough. In our tap water, there's phosphates and nitrates and chlorine and other various metals like copper, lead, mercury. Um, we don't want that in our tank for kind of obvious reasons. The phosphates and nitrates, we all know they're going to create algae blooms, and we certainly don't want them. The metals, copper, lead, mercury, copper especially is an enemy of invertebrate and is highly toxic. So that's why you need one. Unless you want to go to your local fish store and get your RODI water from them, that's your choice. Figure out the cost, the time, whatever's involved, and you'll determine whether you want to buy one, but you need to use RODI water. So make it yourself, buy it, either way, but must use the water. Well, what does RODI stand for? So RO is reverse osmosis. It's one way of purifying water. DI is deionization, a second way of purifying water. So we've got two ways of purifying water in one, in its simplest terms. So RO, and we're going to get to the RO unit, but RO just real quick, what does that really mean? What is it? Why do they call it that? Reverse osmosis just means we're putting a heavy pressure, and that's this. And we're going to see this guy. We're putting a heavy pressure and the membrane in here on one side. We're causing it to not act in its natural flow. Normally it would flow evenly from one side to the other, but we're forcing that. So we call that reverse osmosis. We're forcing the osmosis to happen. So RO. DI, deionization. Deionization, again, in its simplest terms, back to chemistry 101, it's taking the bad particles, leaving them behind in this final chamber, and only leaving the good. And we'll go through these. So let's look at how this guy works. So we have an intake. We have an intake that hooks up to any ordinary garden hose outlet that you have outside of your home. You can also plumb these inside, which I'm going to do, and I'll take a video of that too and show you how it's done. But nonetheless, we have an intake. It leads into the first chamber. This is a sediment chamber, 1 micron sediment chamber. I highly recommend 1 centimeter size or less in that first chamber. We don't want sediment to get into our tanks, and we certainly don't want sediment to get into the RO portion of this unit, because it will destroy the unit. So 1 sediment pre-filter obviously does what it says it does. It takes out sediment up to 1 micron or larger. So second chamber we have is a carbon filter. Second chamber we have is a carbon filter. That's going to take the chlorine out of the water. Obviously, again, another thing, we don't want our fish to be swimming in chlorine. Second reason we don't want chlorine in the unit is after the chamber number 2. After that unit, it's going to go into the RO portion. Now, if you have chlorine in the RO portion, it's going to destroy the membrane. It's a rather expensive membrane. Compared to the cost of the entire unit, it's probably a third to a half of the cost of the entire unit if you want to replace that. So we want to guard this RO membrane, and chlorine is not its friend. So in the RO portion, which is the third place the water travels to, again, there's tiny little holes in this RO membrane, and it squishes the water from one side to the other, and through the membrane. And what happens is the H2O molecules are smaller than all the other bad molecules that we want. Okay? So they're going to fit through the RO membrane. They're going to fit through the small holes in the membrane. The larger particles, the bad part of the water that we don't want, is not going to fit through there. Okay? So what happens is the bad water through this orange tube drains away. Now what I do is I put that in my lawn. It drains into my lawn, and waters my lawn for a little bit. You're going to get 3 to 4 gallons of bad water for every gallon of good water you get out of most RODI systems. So after the RO unit, we're still not complete. That's half of what we need to do. The water's clean at this point in time. We've got mostly H2O, but we don't have 100% H2O. We've still got some of the heavier metals in here. We still got some iron and some copper. There's still nitrates, phosphates, sulfates potentially in here. So we have the final chamber. Again, this is a 4-chamber system. You'll see 2-chamber systems, 3-chamber systems. I highly recommend a 4-chamber system. Any less than that, you're missing out somewhere. So this is a pre-sediment, or this is a sediment filter. What that sediment does is, again, it has positively and negatively charged ions. It's an ion exchange. It's a way to get the metals out of the water. It exchanges things like iron and copper. It absorbs them into here, and it creates and leaves behind hydrogen. So hydrogen, that's the H in the H2O. That's fine to have. So in its simplest form, that's what it does. Then we're left with the blue water, which is the blue line, which creates nice pure H2O, and nothing else. Now an add-on to this thing, to this unit that I'm going to purchase, and I believe the Kent Maxima Hi-S has it already. It has two things actually. One, there's a meter that will measure TDSs, and that's what this is all about. Total dissolved solids. Okay, so there's a meter. One end will connect to your orange, in this case, intake. It will tell you how much total dissolved solids you have in parts per million. The other end of this, again, very inexpensive meter, will tell you in the blue line with the T connection what your total dissolved solids, TDSs, are coming out. Obviously the reading going in is probably going to be 100. The reading coming out better be 0, or it's time to replace your filters, or the system's not working right, and you better troubleshoot it. Don't use that water. I've tested my water as it's come out before. Kent Marine makes a good system, so I've just recently changed all these cartridges. So I know I'm getting good water, but nonetheless, as a double check, get one with a meter. I would suggest getting one with a meter. I'm going to do that. Don't do what I do just because I say it's right, or anybody else on YouTube or the internet. Obviously, do your own research on these things. It's important. It's an investment. You want to be happy with what you buy. Don't just listen to somebody making a video. Again, I do these for me as much as I do them for anybody else. It's my way of kind of remembering all these various things that we need to know as we experiment and play with our hobby. The other thing I would get is a flush kit, which connects up at the top. It just is a way to you divide, or really it works on this end where the water's coming out. It's a way to flush out this membrane. It's another T connection. You turn a valve and it will flush out the membrane of any sediment that may deposit on the bottom. So I highly recommend that. Again, we're going to hard plumb this in to the inside of the house, and we're going to set up a reservoir unit with a float with a shutoff valve. So we'll make our own automatically. You know, it will make it when it's done. It will shut itself off, and that will be for another video. But there's my unit. I recommend it, but again, do your research. The Kent Marine Hi-S RODI unit. Thank you again for watching the video, and stay tuned for more to come.